Hello everyone, myself Hans. Today we are going to solve the given problem from topic definite integral as a limit of sum. Question is given here. Evaluate the sum of the following series, and the series is given here. Limit n tends to infinity 1 upon n plus of n square upon n plus 1 का cube plus of n square upon n plus 2 का cube plus dot 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 1 plus of 8n. Let's solve the problem. Given series is limit n tends to infinity 1 upon n plus of n square upon n plus of 1 का cube plus of n square upon n plus 2 का cube plus dot 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 plus of 1 upon 8n. When we have to solving this type of problem, we have to remember following result here. This is r by n replacing with x, and 1 upon n is replacing with dx, and limit n tends to infinity, and here summation is replacing with integral limit 0 to 1. So first we have to write the given series in the form of r term. We have to writing given series in the form of r term. So we have to writing the given series in the form of limit n tends to infinity, and here we have to writing here this is n square upon n plus r का cube, and here this is r is equal to 0 1 2 3. When we have to put the result r is equal to 0 here, we get the first series here 1 upon n. Similarly we have to put r is equal to 1, we get the second result here. And when we have to put r is equal to 3, we get the third result, and in the last we have to putting r is equal to n, we get the 1 upon 8n. So from here further we have to solving with here limit n tends to infinity, and we have to writing here n square upon, here we have to take n is taking common from bracket, we get here 1 plus of r by n का whole cube, and further we have to writing this is limit n tends to infinity, and this is n square upon n cube, and this is 1 plus of r by n का whole cube. N square to n cube is cancelled out, remaining is here n. So we have to writing here this is limit n tends to infinity 1 upon of n, and this is 1 upon of n once again, 1 upon of n into 1 plus of r upon n का cube. And we have to further discuss, we have to replacing with r by n with x, and 1 by n is n with dx, and limit n tends to infinity, summation represent here integral limit is 0 to 1. So this is the form of, once again, this is the summation form we have to missing here. This is r is equal to 0 to n, and here can also mention here once again limit n tends to infinity, here summation is r is equal to 0 to n, and we can also write here this is the r term, so nothing to affect here. And further we have to replacing the following result here, we get summation limit n tends to infinity, a summation replaced with integral limit is 0 to 1, and 1 upon n is replaced with dx, so I have to writing here dx, and 1 plus of r upon n is replacing with x, so we are writing here x and to the power cube here, and we have to solve the given integral, we get the required result. So we have to using the following result here. This is xn dx is given by xn plus of 1 upon n plus of 1. So we have to write the following result in the form of x to the power n dx. Here we have to writing here, this is 0 to 1 and 1 plus of x to the power minus 3 dx. 1 plus of x to the power 3 is taken to numerator, we get the in the minus power, and from here we have to let 1 plus of x is t, and here differentiating we get here dx is equal to dt, and we have to also change the limit here. When x is equal to 0 we get, when we have to put x is equal to 0 we get t is equal to 1, and when we have to put x is equal to 1 we get here t is equal to 2. So we have to put the change limit here once again. We have to put in here, this is integral limit is 0 to, here we have to change the limit. This is when we have to put x is equal to 0 we get 1, so limit is here 1 to 2, and this is 1 upon x, we have to suppose here t, and here t to the power of minus 3, and dx is equal to dt, so we have to write here dt, and from here we have to use this following result. We get here t to the power of minus 3 plus of 1 upon minus 3 plus of 1, and we have to apply the limit here 1 to 2, and further we have to solving t to the power of minus 2 upon minus 2, and the limit is here 1 to 2. First we have to apply the upper limit, we have to put in here t is equal to 2, we get here 2 to the power of minus 2 and upon minus 2 upon minus 2. When we have to put the lower limit, t is equal to 1, 1 to the power minus 1 is 1, so we have to write here 1 upon of minus 2, and we have to solving here, this is 2 to the power of minus 2 is taken to denominator, we get here 1 upon of minus 2 into 2 to the power of 2 minus 1 upon of minus is plus, so we have to write in here 1 upon of 2, and we get here 2 to the power of 2 is 4, and 4 into 2 is 8. This is 1 upon of minus of 8 plus of 1 upon of 2, and we have to taking LCM here, we get 8 is the LCM, and 8, this is minus of 1, here is 4, 2 4s are 8, we get here plus of 4, we get minus 1 plus 4 is 3, so we have to write here 3 by 8. This is the required result of the given series. 3 by 8 is the required answer. Thank you class, and thank you for watching.